everyone. Welcome to Risk Roundup. Over the years, our traditional approach to cybersecurity has been the use of passwords and password-based authentication. Now, passwords have provided the cyberspace-based digital systems and platforms with a barrier to access what was quite safe in the analog world. However, since the digital age provided the means to quickly try hundreds of thousands of passwords in a short time, the password-based authentication system is no longer considered safe and secure. Now, since hacking passwords have become relatively simple, it is no surprise that we need effectiveness of authentication systems for our digital identity and digital age. As a result, a new approach to identity authentication has become essential. To evaluate the latest advances in one such approach, I'm delighted to welcome Professor Sérgio Magalhães to Risk Roundup. Professor Dr. Sérgio is the Department Chair of Cybersecurity at Champlain College based in the United States. He has also published a book on the viability requirements and implementation of behavioral biometric technologies. He's a widely published author and a very reputed and very impressive work that he has done over the years in this field. Most of the discussion that we'll have today is based on the work that he has done and the articles that he has published over the years. Welcome, Professor Sérgio. We are so very honored to have you on Risk Roundup.
Thank you for having me. It's a pleasure.
Wonderful, Professor. So let's begin our discussion understanding the digital user authentication and the current trends that we see in the market all across nations. Now, it seems that the majority of computer systems employ a login ID and password as the principal method for access security. Now, in standalone situations, if your computers are not connected to the internet, this seems, very effective, and this level of security may be adequate, and, it would be just fine. But when computers are connected to the internet, the vulnerability of a security breach is very highly, increased. So what are the common authentication solutions used today to reduce vulnerability to cyber attacks? And from your assessment, do you think that they are effective?
Yeah, that's a very good question. So we started developing habits in technologies many, many years ago when everything was different, when we had private networks, internet was not widely available, computational power to break passwords was nothing similar to what we have today. And so we developed this fundamental idea that as long as a password is long and is complex, that is good enough. And it was. Authentication, like anything else in cybersecurity, is about balancing the risk with what we are trying to protect, and it was good. But then things changed, as you were saying. To start, the computational power increased exponentially, and so it's much easier to do a brute force attack to a password. But also, users changed. 20 years ago, we could have maybe 2 different username and passwords for 2 different systems. Today, we have hundreds of systems where we are required to log in, and we need a username and a password for each one of those. And that old idea that we should have different usernames and different passwords for each system is no longer viable. Human beings can't have 200 usernames and passwords that are totally different from each other, where each password can't have any semantic meaning, so that we can't use dictionary attacks. They have to be different from each other, and so we should change them often. No, passwords shouldn't last more than 3 months. That doesn't work with what a human being is. But we stayed in that realm, and we stayed in those old habits. And the fact is that when we are providing a service, we want everybody to feel comfortable when they are accessing the system. We don't want to create barriers for our clients and for our users. And passwords are something that users are used to. And so systems continue to use that. And we have seen some changes, especially in mobile devices. We now see fingerprint recognition. We see some facial recognition in mobile devices. So there is a small change in that, but it's just not good enough.
Yes, you're absolutely right. Like you said, the whole system has evolved. Everything has evolved from computing power to users. Everything, everyone, and everything has evolved. And like you said, if each one of us has to keep hundreds of passwords and user ID, how will you remember that? Human memory, is not that strong and is not that efficient that we can recall all different passwords. So we do have to then write it down somewhere, or log it somewhere, or use password manager. But that also brings lot of extra risk. So there is a need for change, and absolutely, because our systems have become much more complex, and everything is going digital. So everybody is using everything, and now right now we are just using human authentication. Now we will have to start worrying about machine authentication as well, because this we are rapidly moving towards making everything smart. Everything is becoming intelligent, from homes to enterprises. Every device, every initiative, we are trying to make it smart. So how do you authenticate each and every device, each and every human being from across nations? It's a very, very complex task. And as you said, FaceTime, I mean, facial ID, not FaceTime. It's so common that it just comes to you. Facial ID and fingerprints. All these biometrics, are beginning to be used, and there is a lot of potential in biometrics. But these biometrics are also from what we see. Like right now, if you see the people wearing the facial mask, the that will not work, because the facial ID, it cannot recognize that. It cannot recognize the patterns. So there are serious flaws in that, and AI can copy that as well. So while we are seeing the trend moving towards the physiological biometrics, do you see that we can effectively use that, or we have to move towards another approach?
Yeah, there's definitely room for those type of biometrics in some situations, but there are a lot of challenges. So even if you think about physical access to a building, for instance, or to a server room, fingerprint recognition is a system that actually works very well. But now with the challenge, for instance, that we are currently living with COVID-19, do we really want everybody to place their finger on the same device? And so there are challenges there, but where the challenge is more obvious is in distributed environments. So if everybody is more and more working from home, if we are accessing services on the cloud, and everybody is using their own machines, we can't expect clients to have the hardware that is needed for most of those systems. A fingerprint recognition system, which is something that people accept there's a high level of acceptance for that type of technology, requires a reader. And if we start thinking about the vulnerabilities of fingerprint, it can't be just any reader. We want something that is able to distinguish a live finger from a dead finger, a live finger from a synthetic copy of that finger. So my daughter is 17 years old. So 17 years ago, I wrote a paper on exactly how to imitate a fingerprint. And we need readers that are able to do that. So from the perspective of a business, we don't want to say my clients are limited to those that have a fingerprint hardware system. So we need something that people are already using and that they are comfortable with. And that's why the work that you mentioned around keystroke dynamics and the way people behave when they are interacting with a machine. In the case of keystroke dynamics, how we type. In the case of pointer dynamics, how we interact with pointing devices or touch screens. That's why that is so appealing, because it's still a biometric enhancement of an authentication system, but it uses exactly the same device that people are using to access our system, and we are not leaving anybody out of our realm. If we move away from business and we start thinking about electronic government, there's also a question of democracy here. Do we want services provided by the government to be limited to those that have a specific type of hardware. And so again, if you can add a biometric layer to something that users must have to, if they are interacting with us, if they are using our system, they are certainly either with a keyboard or with a touch screen. And so if we can add a layer of biometric intelligence to that authentication system using what they already have, and something that is transparent and comfortable to them, that's great. That's a way to improve on the security without leaving anybody behind, without losing market, and also using something that is comfortable for the user.
No, I think you're right about it. The point that you made about your daughter growing and over the years how the fingerprint could change, I think that's an excellent point. To understand where the complexities rise when you are trying to use the physiological biometrics, because it is all about how you collect the data when you collect the data. If you collect the data during the enrollment process of anyone, any child, any human being, at any adult at any point, the environment also plays a role. For example, if you are looking at someone, trying to take someone's retina scan, iris scan, then the amount of light that is around that also can play a role. And now when you are trying to authenticate that, all those variables will come into play. So there are a lot of complex challenges when we try to use these physiological biometrics. And yes, I mean, there are many different alternatives. People are also trying to develop a DNA based biometrics. People are also trying to use brain waves. So there are a lot of different approaches that are experimented, and we will have to see in the coming years where this goes. But the bottom line is that for any of those data, any of those biometric data, how we store them, and if the data that is stored, if that is accessed by any intelligence system, if any AI can copy that, duplicate that, do we have the capability to differentiate that this is AI that is using that data and it's not the human being? So to differentiate whether there is a live human being using that data, or whether that is a any entity, any AI system using that data, is going to determine whether we are successful in our approach. So the alternative that you have been working on is really impressive. I have read almost all of your papers, and that really excited me, because where you are going with this research, I think it's very interesting. Now, I had a discussion with a gentleman from Japan also. He also came up with the idea that instead of using this number password and symbols and all, let's use graphic memory of any event. And I was thinking about that it's very important to investigate this further, and that led me to do more research. And I stumbled across your papers, and I started reading them, because we need an alternative to these text-based passwords or physiological biometric-based authentication system, because these we can use graphical passwords and that could work. But how we should approach that? Should that be only this part of the system that we are developing, that we just use someone's memory, or there needs to be more than that? So what is your assessment of that? If we use just someone's memory and some graphic password, do you think that will be effective?
Well, graphical authentication starts at the ground base by increasing the number of possibilities. So when we have a password with letters and numbers and symbols, there's a number of different possibilities. When we move into the graphical authentication, the number of possibilities is much bigger. So that alone adds a layer of complexity, because now to do a brute force attack, we need to try many more possibilities, makes it much harder. But of course, we see computers progressing. Computational capability has been growing, and it's going to continue to increase, and it won't be enough. But it's good to see, like, again, in the mobile industry, some type of graphical authentication coming up, even if in a limited way. Before going into the biometrical aspect of that, there's another layer that is very interesting with graphical authentication. is that if your system allows the user to upload their own image, then it also, the graphical authentication also serves as an authentication of the system itself. Of course, there can be a man in the middle, but there are ways of working around that. I remember one of the solutions we came up with was that the image, when it comes to the user, actually has the IP address of the person that asked for that image. And so that allows us to know that there is not a man in the middle attack. But the fact that I go into your website, and one of the challenges that we have is all the scams that are around there, and with phishing attacks. How do I know that this website is actually the website that I was trying to access? And it can be challenging. So if I go into a login page, I insert my username, and the system returns an image that I was the one creating, then there's an additional layer of confidence that that website is actually the right one. Then I can go and do whatever it is that is my graphical authentication. I can pick points in the image, or I can make a draw, something like that. But it's very important to also limit the type of images that you can use. We found that people, because there's a limitation to memory, tend to choose, if it's an image of a face, they'll tend to choose the eyes, the mouth, the nose. So because human beings will always be human, we need to make sure that images have certain characteristics that will make it complex to guess what is the secret of that person. But above that, we can come with what we call pointer dynamics. So what's the behavior of this person when picking the points? Not only the sequence, but how fast does that person does it? What's the relative dimension of the dots that are covered by my finger when I'm using that? A lot of behavioral aspects of the way we interact with the touchscreen or with the mouse pad that can be captured in a behavioral biometric and add that additional layer. So I would say that just moving from text-based passwords to graphical authentication is already a great step, but then we can add this layer of behavioral biometric authentication over that graphical authentication to have something that is just not just knowledge-based, but is based on what makes us human, which is how we behave.
Yes, you are absolutely right, and I agree with your approach that if I have to define identification system, then I will make sure that it has many variables, not just one variable that we depend on, because then we are increasing our chances of security. Because to hack into each and every variable will be very difficult, and we can integrate all that, and we can come up with a unique system that will be very difficult for hackers to break into. So from what you are saying, to have that additional layer of behavioral analysis and to make sure that we are focusing on how each and every individual behaves, that is going to be very useful, and I think it will be very effective as well, because it is very difficult. It will be very difficult for any hacker to be able to come up with that. I mean, yes, of course, with a lot of resources and a lot of effort, anybody can copy, understand, anybody's behavior and copy that. But it would require a lot of effort, and the nature and kind of, hacks that we are seeing, that anybody's password or anything can be hacked so easily, that will be, we will be able to eliminate. So from the research that you have done, the keyboard, how we type on our keyboards, what information can be extracted from that typing? What kind of information can be extracted that we can use for the behavior analysis?
Yeah, so the way each person types is very unique. And when we started, so people started realizing that we have patterns in the way we use our hands and we communicate. Long time ago with the telegraph, the telegraph operators would know the person on the other side by the type of rhythm that they would use when telegraphing. And later, people discovered that when typewriting, there was also a pattern. So what Keystroke Dynamics did was kind of build on that for the age of computers. And so what we basically do is basically try to understand what's the relation between the times, between the moment we start pressing, we pressure a key to the moment we release, and then again to pressing another one and releasing that one. Those are the types of times that we measure. And I remember in the early days, I had a paper that I submitted and came with a peer review saying, this can't work because if I have a cup of coffee, it will change my dynamics. And I can understand that it's counterintuitive, but the fact is that even if I'm typing faster or not that fast, or if I'm more tired, the type of relation that we have between those times is unique. So I might be moving faster, so we are not working with the times, exactly the times, but with the relation between those times. And it works. And the fact we had this hypothesis that it could be there could be a relation with the distance of the keys in the keyboard. So we did a few experiments to check if that was the case, and it wasn't. People change from one keyboard to the other, and they need a few seconds to adapt sometimes, but they will still have that same pattern in the relations between how long the key is down and how long it takes for the next key to be down. And that's what we measure. It is very, very good.
No, I believe you, because it is not about this. I don't think these kind of systems are one-time test or is static. You have to continuously monitor the behavior. You have to continuously monitor. So it's not like when you enroll for the physiological biometrics data, you take a one-time retina scan and that is entered into the system, and that becomes a de facto standard. In keystroke-based system, I don't think it is about one time you type it and that data gets into the system and that is it. No deviation can happen from that. So this is, you are trying to understand the behavior in how that human types on the keyboard. So it is more than one time that you are going to evaluate that. So it will be probably hundreds of times you will see that, hundreds of thousands of times how, that individual types on the keyboard. So any deviation, like the example you gave about the coffee cup, those will be eliminated, because in the end, you can make the system intelligent. You can create an algorithm and you can use effectively AI to make this process intelligent. And once it is intelligent, it will be easy to eliminate these kind of instances when somebody is typing or when somebody is, tired, or how that changes, the dynamics. And if somebody is talking and, trying to type at the same time, how those behavior dynamics will change. I think those kind of errors we will be able to eliminate, because we will be able to make the process intelligent. Now, it seems that with the keystroke-based this behavior biometrics, any attributes that we collect for the authentication process, so as we have been discussing, it's not one-time process, but from what you have developed for the system, how often do you update the data? Is it continuously or you?
It is.
Okay,
yeah,
so
what happens is, like in any biometric system, a person enrolls. And when they do the enrollment, they have to type their pattern, their password, or their graphical pattern a few times, so that the system can learn what's that initial pattern. Then, every time that the person successfully authenticates into the system, that new pattern, as long as so there's a margin of acceptable times and patterns. So it's not, you need to spend exactly 5 seconds in one and 4 seconds in the other, or that the second is going to be half of the time of the first. There's an interval there that is acceptable, that the computer says, okay, with inside this interval, this is the correct user. And every time a user successfully logs in, that new pattern is brought into the system, and the oldest pattern that we have is deleted. And this allows for the pattern to progress with the person as the sequence becomes more and more known to the person, and the person is evolving as a human being, but also evolving as a user of that sequence, the pattern evolves with that person, and we delete the oldest one, and we bring the new one and recalculate the new pattern so that the system evolves as the user evolves. And that's how we are able to continue to have a pattern that is a pattern for the user at that moment in time, not a pattern for who that user was 5 months ago.
That's a really good point, because you are evolving your system with time, and you are evolving the system with the user. So as the user gets older, it definitely, some changes will be there in how we use our keyboards, how we do everything. We ourselves evolve. So if the system also evolves with the user, how user is evolving, that would always bring that extra additional step of security and additional step of data. So I like the process that you have developed, because I think it is going to be very effective. Now, once the keystroke data has been collected, how is the reference signature obtained for any of the user? You identify the pattern keeps evolving, the data keeps evolving. So how does this signature work? How does the whole identification and authentication system work? By defining what is that signature, and by identifying every time when someone tries to log in.
So basically, what happens is when you are inserting your pattern, the system captures all that information, and all of this gets encrypted and sent to the server. The server deciphers that, and then it breaks it down to the several components of what we are measuring. And the algorithm that we worked on, what it does is, so you have all of these points that we are measuring, how much time the first key was down, how much time it took from the moment I released the first key to the moment I pressed the second key. All of those points will be inputted into the system as a yes or no inside the interval. And then there's a valuation system that if you I have a yes, 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 that is much better than a yes, no, because there's a consistency in that. So we give points not only for being inside the interval, but also for those consistencies in parts of the pattern. And if it's closer to the value expected, there's a different point for being not so confident about that interval. And all of that generates a value of trust. Let's say, okay, the computer is 85% sure that this user is the right user. And then I keep telling to my students here at Champlain College Online in our cybersecurity program, there isn't never a situation where we want this or we want that, and that is the one size fits all for everybody. It's up to the risk analysis team to say, in this system, with this data that we are trying to protect, under these environmental conditions that we have at this moment, we will allow users that know the secret, because both with keystroke dynamics and pointer dynamics, you first need to know what is the password or what is that graphical sequence. So we will allow users that know the password and that we are 93% confident that it's that person because of the pattern. Okay, above 93, we'll accept them. In a different situation, 93 might be too much. And in another situation, 93 might not be enough. So there's this risk analysis of where's the threshold, that because human behavior is always a probabilistic decision. And well, 20 years ago, it was harder to work with probability, even if biometrics was always about defining a threshold. Now, as we move into quantum computing, people get more used to the idea that we work more with probabilities. But it's understanding that there's an environment. that environment defines a risk for our organization. Our data might be of more value. Like you mentioned before, if we have infinite resources, of course we can probably break any system. But people are going to dedicate to resources that the value of the data makes those resources justifiable. So we need to assess the value of our data, assess the type of users that we have and their capability and their resilience to maybe being rejected one time and having to input the data again, and the risk of the environment. And that's what I keep telling to our students in the cyber program. It's not just about the zeros and the ones and the technology. It's about understanding the society we are in and the people that we are working with. But that's basically that. We have a system of points, and then those points might be enough or not be enough to say we will allow you that know the secret with these points to go in.
Yes, very true. No, that's an excellent point you made, because we have to understand which platforms and which systems in the digital age requires what kind of authentication, because not all the systems require this, very intense authentication process. If you are just going on some website to read, you can log in with some password, but if you don't have any financial data or any personally identified information there, then there is not need for much security. But if you are going to your bank account, or if you're trying to go to do some trading or use some platform where the utmost level of security is required, then we have to see which will be the best options here. So you are right, absolutely right, that each environment we have to evaluate, and we have to see what is the best way to move forward, and what is the probability that we can look at, and what kind of systems we want to use. Now it seems that you have probably done a lot of analysis over the years of all the systems that are out there. So when we compare your system, the Keystroke dynamics algorithm, and evaluate it with other systems, if we have to evaluate its efficacy on one platform, let's say trying to access some kind of financial data or go to the financial system, then how would you rate your system with all these other authentication techniques that are out there?
Yeah, so first it's important to say that I'm not the only person working on keystroke dynamics. A lot of researchers are working on keystroke dynamics. But what I find unfair, to be honest, is to compare a system like keystroke dynamics to a system like a fingerprint system. So when we are using most of the biometric systems, that is the authentication factor. And if you also have a password, that's two factors of authentication that are separate. If a person places their finger, they are placing their finger, that's it. And if the person is inserting a password and placing their finger, they are doing two different things. In keystroke dynamics, the user is doing one thing only. The person is inserting that password or that graphical sequence. Only one step. What this type of system brings is an added layer of security to that one step, without requiring the user to be bothered by an additional step. So we see now a lot of systems requiring two-factor authentication. Very often a text is sent to your phone with a code, and that is also a very interesting system to guarantee the level of authentication. But what does that mean? That means that if I want to access my system, I need to have the phone with me. If I have no battery on my phone, now I can't access it. So I'm creating barriers to accessing the service. And keystroke dynamics and pointer dynamics don't create barriers, don't create additional effort on the user.
Very true. So, like an invisible layer, right? I mean, you wouldn't even know that how your thing is being analyzed. So that's really very effective, because once you enter the system, it is silently you are being audited, you are being authenticated, and you won't even have to worry about, like you say, the two-factor authentication, which is also working well for most of the systems. But this is an additional, silent, invisible layer. I think it's really impressive, and it could work. And in one of your paper, you say that the precision of biometric technology is usually measured by its false acceptance rate, the permeability of the algorithms to attacks by its false rejection rate, the resistance of the algorithm to accept a legitimate user, and by its crossover error rate, the intersection point of the FAR curve and the FRR curve that indicates the level of usability of the technology. So, what is the precision of the keystroke based authentication technology? Because it looks like you have done a lot of quantitative analysis here.
Yes. So in the beginning, we were not actually too worried about that. In the beginning, we were basically trying to understand, is this feasible? Can we use this? And there's a very interesting paper by Peacock that compares several systems, and we could see everything from 4% to 20% in that crossover error rate. Now, we have systems that have crossover error rates around 2%. But for me, the crossover error rate is very interesting from an academic perspective, so that I can compare and see, is this feasible? But what I'm more interested about is, what is the false acceptance rate? How many times an intruder will go in at a false rejection rate that I can accept? So let me try to give an example of this. We've all seen people placing their fingers multiple times in the computer trying to log in. One time didn't work, 2 times didn't work, 3 times didn't work. And if I accept that a person must have to introduce their password sometimes 2 or 3 times because it doesn't work at the first time, if I accept that level of effort for the user, what is the false rejection or the false acceptance rate that I have? And we now have keystroke dynamics that if a person on average has to submit their password twice, then it's almost impossible for an intruder to go in. It will be an intruder that already knows the secret, already knows the password. 1 in 10,000 times would be able to go in. And we are talking about somebody that already knows the secret, and we are supposed to keep the secret. If we increase the average time that the people have to insert the password, we have even more security. But on the other side, so if we are talking about maybe armed forces environment where we have a very strong security that needs to be in place, users will understand, okay, sometimes I'll have to introduce my password twice or even 3 times to be able to go in, because we are looking for this extraordinary secure system. If I'm in an e-business platform that now is working just with the password and nothing else, I might make sure that the person only has to introduce their password once, no additional effort, no barrier to the client. And even if the person already knows the secret, still 96% of the times that they try to come in knowing the secret, they will still be blocked. And there's that margin of the threshold that is different for different people, different for different systems, different for different risk analysis, that the keystroke dynamics allows us to make. And that's what makes it so appealing.
Yes, very true. Now, the algorithm that runs this, keystroke behavioral analytics in the background, what is the processing capability of that algorithm?
In what sense? In terms of how many people, or
yes.
From our experiments, we have grown this to situations where we had thousands of users, and it doesn't add a lot of computational needs. It's very efficient. The communication itself is a little bit more demanding because information is going encrypted there. But it's a small sequence, and so it's not much more than what you just get for having HTTPS instead of HTTP. So with the new type of networks that we have, it's the additional effort and even the additional costs that come with that, energy, hardware, maintenance, it's not that much, and it's really scalable. And so, again, I know I'm biased because I've been working in this system for so long, but it's a very interesting add-on to systems provided by governments, by industries, that creates no barrier, doesn't add a lot to the costs, doesn't require hardware that is better than the ones we commonly have now. We could implement this on a smartwatch with no problem at all. And so it's a very appealing technology, and I believe that in the near future, we'll start seeing more and more of this.
Oh, absolutely. I do agree that it's a very appealing technology, and I think that there is a lot of potential there. But if we see human behavior, it changes with time. And we discussed that, earlier also, that how, your system, keeps evolving with the, evolution of the human itself, as human grows, or, the ways change and all that. So this algorithm, it seems that it promotes a strategy for a dynamic pattern store that allows it to evolve with the user keystroke changes. So do you see that there is a need for further studies, or is this system ready to be applied and commercialized?
Well, it is definitely ready to be applied and commercialized, but we always need more studies. We can always use new artificial intelligence techniques to make it even better, make it more efficient in terms of computational, the algorithm that makes the computation, make it more efficient, looking for something that we missed on the data. But there's always room for science to evolve. But as it is now, it's definitely ready to be implemented in commercial solutions. And there was a company that used it a couple of years ago. And I was kind of surprised that they stopped using it, not because it had any type of problems, it was working just fine, but because their risk analysis said, we don't need to have an additional layer, it's just fine as it is. As passwords are fine for our system just because we don't have that threat. I was surprised that they made that call, but it also comes with my philosophy that if you don't have threats and the data that you're protecting doesn't need to be protected, it's just kind of, okay, let's know who this person is, but not because we are protecting that data. So let's save the database and save that computation. It is aligned with my philosophy, even if I don't agree that data is of no value at all. So, but that was a real interesting experiment with thousands of users, and it kind of served to prove that the system works. And so it's definitely ready to be implemented and commercialized.
That's great. So earlier you mentioned that there would not be any scalability issues if we have to, scale it at a level where, let's say, for the entire country, needs to use it. You think it would be ready, and the algorithm would keep up with that kind of, large scale national level implementation?
Yes, definitely. Of course, when we scale it to millions, any system, even fingerprint,
Yes.
when you scale it to millions, what happens is that the number of collisions increases, because even if all fingerprints are different, we don't measure the entire fingerprint. We measure points in the fingerprint. What that makes is that if we are doing a system for 50 people, we can measure 5 or 6 points. If we are measuring it for millions of people, we need to measure more points in the fingerprint. And for a keystroke dynamic system to work on itself, and we would need to define that passwords can't be 4 characters long. They would need to be, for a country like the US, hard guess, probably 7 or 8 characters long for us to have enough points to make all of them distinguishable. But yes, definitely, this is a type of system that supports a system for 100 million users without requiring extraordinary measures, extraordinary hardware. Of course, we need to have databases that support 100 million users, but the hardware that is common for that type of systems, it would be more than enough to keep up with this type of algorithm.
Yes, absolutely. No, I think it's a very impressive work, and I think there is a lot of potential in the coming years. This would likely be, integrated with some other, approaches that we have. It would probably, people will not use this, as a standalone system, but as we discussed before, that we use facial ID with that, we use, a graphic password with that, and then, this kind of behavioral keyboard analysis, then those kind of systems will be very difficult for anybody to break into. So yes, there is definitely a huge potential for this to be commercialized. And on that point, what would you like to tell our global viewers and listeners about your how to reach you if anybody is interested in discussing how to take this to the next step and commercialize this?
Yeah, so I work at Champlain College Online here in Vermont, USA. You can go into our website and find me there, because I'm the program director for the undergrad program in cybersecurity and the grad program in digital forensic sciences and the undergrad program in software development. So if you look into any of those programs, you find me there, and there's my email address there. And I'm always happy to work with the community, work in industry, with other scientists. So anybody that is interested in talking with me about this and discussing this, they are welcome to track me on our website and just send me an email. I'll be happy to talk with anybody.
Wonderful. So thank you so much, Professor Magalhães, for participating in Risk Roundup today. We appreciate your thoughtful insight on a machine learning approach to keystone dynamics-based user authentication, and I'm sure our global viewers and listeners will benefit tremendously from the information you provided. And as a result, this Risk Roundup dialogue has been of service, and we thank you for that.
Thank you for having me.
Wonderful, Professor. So Risk Group is a strategic security risk research platform and community, and our strategic security community and ecosystem is the first and only cross-disciplinary and collective community that is made of top scientists, security professionals, thought leaders, entrepreneurs, philanthropists, policymakers, and academic institutions from across nations collaborating to research, review, rate, and report strategic security risks to protect the future of humanity. Add your voice to risk groups. To find out how you can get involved, please go to riskgroupllc.com. Until next time, I'm Jayashree, host of Risk Roundup, signing off. See you next time. Thank you.